Hi everybody. So in this video, we're going to look at carrying out a hypothesis test using the geometric distribution. So we'll work through example 1 and example 2, and then we'll try some exam style questions. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So we're told in example 1 that a single observation is taken from a geometric distribution and a value of 16 is obtained. We've been asked to use this observation to test HO, and we call this our null hypothesis. Now the probability of success P is 0.2 against our alternate hypothesis H1 that P is less than 0.2 using a 5% significance level. So when we carry out our hypothesis test, we need to assume that P is a 0.2. So we can define our model that X is distributed geometrically with a probability of 0.2, where X is the random variable, the number of attempts needed for the first success. So we've got the sketch of a geometric distribution, and we can see that the peak of a curve occurs at the expected value. And we can work out this expected value as 1 over p. So in this case, 1 over 0.2, which is 5. And this tells us we would expect 5 trials for our first success. And we're given in the question that the first success occurred on the 16th trial. And we can see this is to the right of our expected value. So we're looking at this region here. And this is called our critical region. And we're told that this has an area of our significance level of 5%. This is an area of 0.05. So we need to find out whether the 16 falls inside the critical region or inside this region. So if the probability of x being greater than or equal to 16 is less than 0.05, then we fall in the blue region and we reject HO. If it's greater than 0.05, we fall to the left, and this is where we accept HO. And we can use this equation to work out that probability. So the probability of x being greater than or equal to 16 will be 1 minus p, so 0.8, to the power of x minus 1. And 16 minus 1 is 15. And we can work this out, and we get 0.03518. So that means the 16 would fall inside this region, so it'll be about here somewhere. Okay? So our conclusion is that because 0.03518 is less than our significance level of 0.05, we say there is evidence to reject HO and support the alternative hypothesis H1. Okay? Let's try another question. Okay, so for example 2, we're told that y is distributed geometrically with a probability of success p, and that a single observation of y is obtained at y equals 4, and we've been asked to test at a 5% level of significance. Now our null hypothesis is that p equals 0.03, and our alternate hypothesis is that p is greater than 0.03. So if we define our distribution, that y is distributed geometrically with a probability of 0.03, and we work out our expected value of y as 1 over p, then this will give us 33.3 recurring. And we can mark this on our distribution as our expected value. And we've been given the observation of y as 4, which is to the left of the expected value. So we're looking at this region here. I'll label this 4. And again, because we've got a 5% level of significance, this critical region has an area of 0.05. So we need to find out the probability of y being less than or equal to 4, which we can do using this equation. This will be 1 minus p to the power of y. So we'll have 1 minus 0.97 to the power of 4. We can work this out and we get 0.1147. And you can see this probability is greater than with 0.05 in the critical region. So we can say that since with 0.1147 is greater than our significance level of 0.05, there is evidence to accept HO because it falls to the right of our critical region where we accept HO. Okay? Let's drive the exam style question. So in example 3, we're told that James claims that he can successfully hit a bullseye in archery 25% of the time. His coach suspects he is overestimating his skill. To prove his accuracy, James takes consecutive shots until he hits his first bullseye. He lands his first bullseye on his 11th attempt. We've been asked to test the coach's claim using a 5% level of significance, clearly stating our null and alternative hypotheses. So do you want to try this question yourself? You can pause the video and come back when you're ready. So we need to define our null hypothesis, which comes from here, and that p is equal to 0.25. And our alternate hypothesis comes from this statement, where if the probability is being overestimated, then we're testing that p will be less than 0.25. We can define our model that x is distributed geometrically with a probability of 0.25. And now we need to define what x is. So we'll say that x is the random variable, the number of attempts needed for the first success. Then we can work out our expected value of x as 1 over p, which gives us 4, and we'll label this on the diagram. And we've been told that he lands his first bullseye on the 11th attempt, so we're looking at the region to the right. So this is our critical region here. And we're given that the significance level is 0.05. So this is the area of this critical region. And then to find out whether the 11 falls to the left or to the right, we need to calculate the probability of x being greater than or equal to 11. And we can do that using this equation. So this will be 1 minus the 0.25 to the power of x minus 1, which is 10. So we've got 0.75 to the power of 10, which gives us 0.0563 to 4 dp. So because this is greater than a 0.05, we know it falls to the left, so about here somewhere. So this means that we'll accept HO. So our statement is that since 0.0563 is greater than the significance level, there is evidence to support James's claim and accept HO. So it's really important that we make our statement back within the context of a question. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.